Welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 21, merge two sorted lists. So for this problem, you are given the heads of two sorted linked lists, list 1 and list 2. So both of these linked lists are sorted in ascending order. And what you want to do is merge the two lists into one list, and that list should also be sorted. And it should be using the nodes from list 1 and list 2. And you need to return the head of this merged linked list. So how would you do this? Well, the intuitive approach would be to have two pointers. One pointer starting at the head of list 1 and one pointer starting at the head of list 2. Then you could check each value at each pointer, and you would check, is list 1 value less than or equal to list 2? And if it is, then you would take this value and you would make a new list using your lowest value, and then you would move your pointer to the next value, and then you would again check list 1 dot value and list 2. Now list 2 is the smallest one, so you would take the value from list 2 and you would use that. But where are you going to be adding these new nodes to? Well, you can add them to a new list, but when you say you create the new list, at the beginning of the new list, you have no nodes. So there's an edge case there. So one thing you can do to make things simpler is to use a dummy node. And the dummy node is going to have a value of any, it doesn't matter what the value is, it could be any value. So we're going to use negative infinity. So we're going to make a dummy node, and it's going to have the value of negative infinity. And we're going to have a dummy pointing here. So we need to keep a reference to the head of this dummy, and then we need to have a pointer that moves so that we can keep adding to the dummy. So we're going to have a dummy, and then we're going to have a pointer that is originally pointing at the head of the dummy. And now, so we're going to do our check. We're going to do, is list 1 dot value. So let's put our pointer back at the top of list 1. So is list 1 dot value less than or equal to list 2? Well, list 1 is equal to, so we're going to say that our dummy dot next, we're going to, our pointer, we're going to have we're going to call this our merged pointer, and we're going to say our merged list pointer dot next is going to be equal to our list 1. So we're going to say that's 1. And then we're going to move our list 1 pointer here. Now we're comparing 2 and 1. So which one is lower? It is list 2. So list 2 is going to be, so now we're going to move our merged pointer here, and our next is going to be what our list 2 was. So that's 1. Then we're going to move our list 2 pointer here. So now we're comparing 2 and 3. So 2 is less than 3, and before we do that, we're going to move this pointer here, and 2 is less than 3, so our 2 is going to be the next. And then we're going to move this pointer here. And now our 3 is the lowest one, so the 3 is going to go next. And we're going to move this here. Now the 4 and the 4 equal, so we're going to it doesn't matter which one we use, so we're just going to use this one. And we're going to make our next our 4. And now we've gotten through one of our lists, and this pointer is pointing at none. So we've gotten through one of our lists. So now, since we've gotten through one of our lists, there might be more. We can't compare any more items with one another because one of the lists is complete. So, but there could be more items after the end of the second list. So there could be 5, 6 here. So what we want to do is just return if there are any extra elements at the end of here, just add them all to the end of the list. But there's only one thing added to one thing at the end, so we're just going to add that one thing, and then its pointer is pointing to none, and that's the end of the list. And then we just return. So our merged kept moving, so now our merged pointer is right here. So instead of returning our merged pointer, we want to return our original dummy, but we don't want to return the dummy head, because remember there's a junk value at the top of the head. So we want to return dummy dot next, and that will give us our entire merged list. So that is how you do that problem. So let's see the solution coded up. All right, so the first thing that we need is we need a dummy head, and we're going to make our dummy a new list node, which this is a class that we're given, and we're just going to give it the value of negative infinity. And it doesn't matter what value we put here because we're ultimately going to be just throwing this away. So, but we're going to give it negative infinity because that's like an impossible value. So we're going to give our dummy node negative infinity. If we wanted to keep it as an integer, we just could have put 0, we could have put -1, we could have put anything. So now we have our dummy node. Now we want to get a reference to our dummy node that we're going to keep moving. So we're going to call that our merged, standing for a merged list, is equal to our dummy. Then we're going to do a loop while both of our lists are not pointing to none. So while list 1 and list 2, we're going to do something. So we're going to, while we're in the loop, we're going to compare list 1. So we're going to say if list 1 dot value is less than or equal to list 2 dot value, then we're going to add list 1 to the new merged list. So we're going to say merged. So the merged pointer is on the starting with the dummy node. So we're going to say that its next value is going to be equal to list 1. So we're putting the list 1 value, the list 1 for the merged next. And then we're going to move the list 1 pointer ahead because we already used it. So we're going to say list 1 equals list 1 dot next. Then we're going to, so if it's not less than or equal to, then that means that the smaller value is list 2. So if that's the case, then we want to add list 2 to the merged list. So merge.next is going to be list 2. And we're going to move our list 2 pointer to be the next value equals list 2.next. Finally, so now we've added our next value in the list. So now we need to update our merged pointer to move to the next value so that we can add the next value after that and the next value after that. So we're going to say merged equals merged dot next. And so finally, we're done with our loop. So our loop stops when list 1 is at none or list 2 is at none. But one of the lists could still have extra values in them if the lists aren't equal, if the length of the lists aren't equal. So if list 1 has extra values in it, then we're going to update merge.next to tack on all of the values on list 1 on to the end of merge.next. So list 1 is going to have, if it has extra values, it's going to have list 1's value and then in its .next and .next and .next. So you only just need to say merge.next equals list 1, and that'll append all the rest of the values from list 1 onto the end of the merge list. And if it's list 2, else if list 2 is the list that has extra values, then we're going to add to merge.next, we're going to add list 2. And if neither of them have extra values, then we're not going to do anything. And then finally, we don't want to return dummy, remember, because the head of dummy has a negative infinity in it. So we don't want to return dummy. The actual list starts at dummy.next. And so we return dummy.next, and that's the code for merging two sorted lists. So let's run this. And I misspelled list node here. It should be list node, not list none. And we are getting a correctly sorted, merged list. So let's submit. And it was accepted. So that's the code for merging two sorted lists. Thanks for watching, and I'll see you in the next video.